In this chapter, we're going to talk about nutrition and metabolism. So metabolism basically consists of all of the chemical reactions that are happening in your body that help transform food, which is nutrition, into energy that your cells can use to power themselves and stay alive. So the food that we eat is our source of energy for all cellular function. And in order for us to be able to build new cells or build raw material in our body and our tissues and organs, we have to have food available to do so. And so when we are eating food, we can look and figure out how many calories are in that food that we're eating. And what a calorie is just a measurement of energy that can be given off from that food once we eat it and digest it. So 1 calorie that you look at on the back of a nutrition label on a candy bar, for instance, that calorie tells you the amount of heat that raises, or 1 calorie is the amount of heat that raises the temperature of 1 gram of water 1 degree Celsius. So when you look at calories on a nutrition label, what you're actually seeing are kilocalories. Kilocalories are equal to 1,000 dietary calories. So a true calorie is only 1/1000th of what a calorie that you're looking at on a nutrition label is. So again, there are actually 1,000 calories in 1 dietary calorie, or 1 kilocalorie, which is what we're looking at on those nutrition labels. So the more calories you have in the food, theoretically, the more energy you can release from that food when you digest it. So where do these calories come from? What are our food sources? There are really going to be 3 major ones: carbohydrates, proteins, and fats. So carbohydrates and proteins are going to contain about 4 kilocalories per gram, whereas fats will contain 9 kilocalories per gram. So you're going to be able to get more energy typically through eating fats than you would through the other 2 nutrient groups. So let's look at calorie sources and look at nutrients. So where do we get calories from? We can get them again from carbohydrates, proteins, and fats. Adults are typically recommended to eat between 2,000 to 2,500 calories per day, and that just depends on the person and what their activity level is. Some people eat much more than that. For instance, people who are training for marathons and things like that may need more calories than the typical person. So this is just an average count. And counting calories, keeping up with calories doesn't guarantee a healthy diet. You still want to make sure that you're eating a well-rounded and well-balanced diet that includes vegetables, fruits, whole grains, lean meats, things like that. If you're only eating processed foods, which are easily digested, they're going to provide a lot of calories for you, but that's going to help increase your risk for depositing more fat in the body, because you don't have to use as much energy to break those processed foods down as you do to break down foods like vegetables and fruits, for instance, that have more fiber in them. So we know that fuels are going to be oxidized to extract energy from that food that we're eating, and that energy is going to be used to produce ATP in our cells. So let's look at the different types of nutrients that we can get from this food. There are 6 major classes of nutrients. First, we have the macronutrients. These are going to include water, carbohydrates, lipids, and proteins. So these are called macronutrients because we need them in large amounts. We need them in large quantities. Whereas micronutrients, we don't need as many of these. We can consume these in smaller quantities, but they're still necessary for us to stay healthy. And those include minerals, things like calcium and phosphorus and iron, as well as vitamins. So vitamin A, B, C, all of those different vitamins that we'll go through. Those we don't need as in high of quantities as we need the macronutrients, but we still need them nonetheless. So your recommended daily allowance of a nutrient is an estimate of the daily intake needed for the nutritional needs of most people. Now, there are some nutrients that can be produced by our bodies whenever we do not consume them in our diet, but there are some called essential nutrients that we cannot produce. And so these are ones we have to get from our diet. And these include minerals, most of the vitamins, many amino acids as well, which are the building blocks of proteins, and a few fatty acids. So those we would have to consume in our diet. We would not be able to produce those on our own. So let's start by looking at carbohydrates first. These are going to include the sugars and starches. And these are going to provide the most fuel for us for cellular work, because our bodies, our cells, like to use glucose as its primary sugar source to produce ATP. And so glucose is going to come mainly from carbohydrates. We're going to get glucose most easily from carbohydrates. So these are going to be required in greater amounts than any other nutrient, except for water. We're obviously going to need more water, but we require carbohydrates more so than any of the other groups, because carbohydrates release a lot of glucose, which helps us produce a lot of ATP in our bodies. So where we get carbohydrates from, many of the carbohydrates, healthy carbohydrates, are going to come from plant matter. Starch is the only important polysaccharide nutrient, and so we're going to get it from certain types of grains and root vegetables, things like potatoes. Cellulose, which is found in plants, is not a nutrient source because it does not get digested, and so we're not going to be able to use that. Disaccharides, these are more complex sugars than monosaccharides. For example, sucrose, which can come from sugarcane, or lactose, which can come from milk. Those are examples of disaccharides. Again, just slightly more complex carbohydrates. Monosaccharides are the simple sugars that we can get from carbohydrates. So these would be like things like glucose and fructose. So monosaccharides, again, these are produced when we break down starch, when we break down disaccharides, and these include glucose, fructose, and galactose. We know that blood glucose is the only monosaccharide present in the blood in high amounts or significant amounts, and we can regulate those blood glucose levels using two hormones that we talked about back in the endocrine chapter, insulin and glucagon. So remember, those hormones are antagonists to help regulate blood glucose levels. Some cells will rely only on glucose for fuel, and so we do need to have this glucose available, which is again why carbohydrates are so necessary in our diet. We talked about hyperglycemia and hypoglycemia back in the endocrine chapter. Hypoglycemia is where you have low blood glucose, and we know that that can cause some problems in the nervous system because, again, certain types of cells, like neurons for instance, only rely on glucose as their fuel source, and so we need to have glucose available at all times. Ideally, most carbohydrate intake is going to be in the form of starch, and so foods that have starch in them usually are going to have other nutrients too. They're going to have some simple sugars, some empty calories, and there's going to be some sugar, a lot of sugar in processed food. So moving to things like candy bars, candy, cereals, any kind of processed food that is preserved will typically have a lot of sugar in it. And so the sugars, again, have a lot of empty calories. It's very easy to digest those simple sugars, and so you're not going to burn very much energy while you're digesting them, which means you're really just going to take all of that energy on. You're going to store a lot of fat because of that. Those simple sugars get stored as fat, and it can cause problems in the teeth, can promote tooth decay as well. Now let's take a look at fiber. So dietary fiber is fibrous material that resists digestion. We cannot fully digest fiber. So examples of this would be like complex carbohydrates found in plants, like cellulose, or other types of non-carbohydrates that are, again, typically going to be found in plant matter. We are not able to fully digest or process these complex carbohydrates, and so we have to rely on bacteria in our colon or large intestine to process these complex carbohydrates. And these are, again, this is fiber. So fiber is stuff that we cannot digest on our own, that we have to rely on bacteria to be able to digest in our large intestine. It is an essential component of our diet, though. And there are two different types of fiber that we can get in our diet. We have what's called water-soluble fiber and water-insoluble fiber. So water-soluble fiber is going to include pectin and other carbohydrates that we can find in things like oats, beans, and peas. And this type of fiber is mainly there to help reduce blood cholesterol levels. So if you want to keep your blood cholesterol at a healthy level, it's always good to have plenty of water-soluble fiber in your diet. Now, water-insoluble fiber includes plant matter like cellulose and lignin. And this is not going to have any effect on cholesterol levels, but it's going to help keep your bowels regular by absorbing water and softening the stool and preventing constipation. So if you're not getting enough water insoluble fiber in your diet, a lot of times you will absorb too much of that water from the stool and it will become very hard, very compacted, and that can increase your risk for constipation. It can also increase the risk for disorders like diverticulitis and colon cancer if that stool stays still, right? It's not moving as it should through the large intestine. It can cause some problems in the digestive tract. So maintaining high levels of water insoluble fiber, again, keeps the bowels regular, and it's going to prevent constipation and other types of disorders in the digestive tract. So now let's move on to lipids. So lipids are energy storage molecules, and we can break into these and release energy from them as well as we can with carbohydrates, but this is our body's kind of secondary fuel source. Once we burn through all the carbohydrates, that's when we start tapping into lipids for energy production, for ATP production. Some examples of lipids that we have in the body: phospholipids we can find in our plasma membranes of our cells. Cholesterol we know is going to be found pretty readily throughout the body. We have it in our cell membranes as well. It's a precursor for a lot of steroid hormones like estrogen, testosterone, for instance. And it's going to help form bile acids or bile salts, which we talked about in the urinary system chapter. So fat in physically active and healthy young adults is going to make up about 15% of the body mass in males and about 25% in females. Obviously, if you are more sedentary, you're not moving around as much, that fat composition can increase. And obesity is where you have excess body fat that is at a higher level than normal. And that can lead to health problems if you have too much fat composition in the body. So fat is used as an efficient way to store energy. It contains over twice as much energy as carbohydrates. And we know that fat is going to be hydrophobic, meaning it does not mix well with water. It contains almost no water, and it's a more compact energy storage substance than carbohydrates are. Carbohydrates, on the other hand, are hydrophilic, meaning they can absorb water, and they're going to occupy more space in the tissues overall than lipids are. Now, when we look at dietary fats, how we can get our fats from our diet, we have two main types. These are called saturated fats and unsaturated fats. Saturated fats are mainly going to be found in animal fats. So these are going to be found in meats. We have them in egg yolks. Cholesterol is the major fat that we see in egg yolks, and in dairy products. There are also fats called trans fats, which are manufactured fats. These are ones where we took an unsaturated fat, which is a liquid at room temperature, and transformed it into a saturated fat, which is a solid at room temperature. So an example of this would be like margarine, where they take vegetable oil and solidify it into margarine. And this can increase the risk for heart disease if you eat too many of those trans fats. They're really not going to be good for you. Saturated fats are going to be a little bit better than trans fats in terms of heart health. Unsaturated fats, on the other hand, are typically liquids at room temperature, and they're mostly going to come from plant sources. So examples of this would be like olive oil or avocado oil, certain types of oils that you find from nuts, seeds, or other types of vegetables. So the body can synthesize most fatty acids, but it cannot make essential fatty acids. And so we have to get essential fatty acids from our foods that we eat. And fat should account for no more than 35% of your daily caloric intake. So you do want to have fats as part of your diet, but they should really only make up about 35% of your daily intake of food. And then no more than 10% of your fat intake should be saturated fat. You really want to try to stick to those unsaturated fats, those vegetable-based fats, those oils. So looking at cholesterol now, cholesterol again is necessary for cell membrane stability and fluidity of the cell membrane, and it's necessary for steroid hormone production. If cholesterol levels are too high, that can increase your risk for heart disease. We know that cholesterol levels are typically going to be more determined by genetics than diet. If you have a close family member, a mother or dad who has high cholesterol levels, then you're probably going to have to keep an eye on that, and you're going to be at higher risk for also having high cholesterol because of that. So levels of cholesterol are going to be raised by eating certain types of saturated fatty acids. Again, we can increase levels of cholesterol by eating egg yolks. Certain types of red meat can increase cholesterol, and certain types of dairy products as well. So now let's take a look at lipoproteins. So lipoproteins are carrier structures that allow hydrophobic lipids to be transported in the blood. So they basically bind with these lipids and help transport them through the blood. And there are 3 different types of lipoproteins that are classified based off of their density. We have high density lipoproteins, low density lipoproteins, and very low density lipoproteins. So let's start with the low density and very low density lipoproteins first, and then we'll get into the high density lipoproteins. So here you can kind of see that lipoprotein structure and composition. Looking at the very low density lipoproteins, these are produced in the liver, and they are used to transport fats or triglycerides to fat tissue in the body to help us store those fats. Low density lipoproteins, LDLs, are going to result whenever triglycerides are removed from the very low density lipoproteins. These are going to contain mostly cholesterol, and these are going to be used to transport those lipids to tissues and organs in the body, the organs that need cholesterol, such as those trying to produce steroid hormones. We need cholesterol as a precursor for the production of steroid hormones. Now, low density lipoproteins are typically going to be nicknamed bad cholesterol because they're going to be transporting fats to the tissues and to the cells of the body. And so that's going to increase the risk for arteriosclerosis or atherosclerosis. HDLs, on the other hand, these are high-density lipoproteins, and so their whole purpose is to take these fats, this cholesterol, and to transport it to the liver to be removed and to be broken down. So these HDLs are going to help us remove excess cholesterol that's present in the blood, clean that cholesterol out. And so these are going to be nicknamed good cholesterol, good lipoproteins, because they're helping us to remove excess cholesterol from the blood, which is going to reduce the risk of atherosclerosis. So again, high HDL is going to protect against atherosclerosis. This is going to be promoted by exercise, diet in low calories, and low saturated fats. And again, high HDL, high density lipoproteins are going to be, good for you. Now, if you have high low density lipoproteins, this is not going to be good because the LDLs, remember, are the bad cholesterol. So if you have high levels of these LDLs, that could be a warning sign for atherosclerosis, which can signify a high rate of cholesterol deposition or deposit in the arteries of the body. So if you have a diet that is very high in saturated fat, if you smoke a lot of cigarettes, have high stress levels all the time, that can increase your risk for having high levels of low density lipoproteins. So we'll look at proteins in a later video. Let me know if you guys have any questions so far.